everybody, to our Database and Memory Office Hours session. Today we're going to talk about heat map, something that I think hasn't gotten that much attention and is kind of what I think is a little gem of a feature that can be used, and we'll kind of talk about how that works. I have special guest Gregg Christman, who's our advanced compression product manager. So you get both of us today. One of the reasons is because heat map originally came out as part of advanced compression and then got added to database and memory. So we'll go over a little bit of that history and how you might make use of it. Our landing page, I always usually start with that up, mainly because don't forget that down, if you scroll down, we have not only all of our previous sessions, and there's actually, I think, a couple pages of those now, but also some resources if you have interest in what we're talking about or anything else associated with database and memory. I have a link to our blog, our oracle.com page. I also have OTN, I should change that. Documentation, the In-Memory Advisor, if you want to try out the In-Memory Advisor, see if perhaps you have workload in your database that could take advantage of database and memory. And then our Live Labs environment where you can actually try it out for yourself in the Oracle Cloud. And so with that, I will switch over maybe to my presentation. There we go. And we can get started. We have some slides kind of describing what heat map is. There are a few caveats to it. And then I do have a demo we can kind of play around a little bit with. It'll be pretty short. And really the idea is just to make you aware of heat map and what you might be able to use it for, in addition to the other features of both advanced compression and database and memory that use heat map. And I think we have our contact information here. Follow us on Twitter. If you have questions afterwards or anytime, our email addresses. And then if you have questions about what we're talking about or anything else associated with database and memory or advanced compression, feel free to type it into the Q&A. I actually have my the chat window and the Q&A open just in case. Sometimes folks will put it in either one. So we'll try to answer any of your questions as well. And so with that, I guess we can go ahead and get started. Anything you want to add, Gregg?
Nope, sounds good.
Okay. So motivation. So really, heat map is really the foundation, if you will, of, and certainly initially, Oracle's ILM, or Information Lifecycle Management strategy, the idea of being able to track the access of objects or segments, depending on how you look at it, for instance, partitions or subpartitions, and then being able to classify those. And we have a feature called automatic data optimization that allows not only compression. So if, say, objects are infrequently accessed, you might want to increase their compression level to have them take up less disk space, but also to allow you to tier the data to different levels of storage. So if you have multiple tiers of storage, and to be honest, I don't know about you, Gregg, but do you run into folks that have multiple levels of storage?
You know, it's if anything, they've sort of separated their table spaces into, these are sort of most active tables and partitions, and these are the colder tables and partitions in a separate table space. And I've seen them sort of have it tier the database on that as one way to look at it, I guess.
Yeah, I think that back in, this feature came out as part of 12.102, which is kind of back in the 2014, maybe even a little bit earlier than that time frame. And the thinking then, I think, was that people would have either NFS mounted storage or what was it, ZFS devices, and ZFS supported HCC even. As I recall, correct me if I'm wrong, but I think it even supported HCC, or maybe it still does. And the idea that folks would have a very fast disk-based tier of storage, and then slower storage where they might, rather than archiving data and taking it out of the database, never really worked all that well. So the idea was, well, maybe we can tier that then to other lower cost storage platforms, and still be able to access that within Oracle database, not having to like re-import it or reattaching it. And so that was kind of the longer term archiving strategy, but I'm not sure that ever really panned out all that well. So I don't know that very many people take advantage of the tiering portion of it, but I think they do use the compression and being able to automatically, or even based on usage, even if it's not automatic, being able to tier data to higher levels of compression to save space. So hence the advanced compression part. And he's nodding his head there. So I assume that's kind of what we're, yeah.
I mean,
and then, oh, sorry, go ahead.
Sorry, that was sort of the best practice approach, right? Is that if you had advanced compression, presumably you had it because you need it for a heat map and ADO, and you had hybrid columnar, then the sort of the best practice, if you will, was to, as the data starts to age, then you start changing the type of compression from advanced compression to hybrid columnar. And there's multiple levels of hybrid columnar, and you could change which type of columnar based on how cold the data was. So the best practice was sort of following the age progression of the data and applying different compression to it as it starts getting colder and colder and colder.
Yes, and then in 12.2, we added support for that scenario, and as you see the picture in memory at the top, to database in memory. So then the idea was that since in memory, or memory in the SGA, if you will, the column store is fairly limited and reasonably expensive in the sense that it's hard to have, not a lot of folks will have terabytes of storage. And so conserving and getting the biggest bang for the buck, if you will, out of the in-memory column store, kind of flowed naturally then to extend automatic data optimization policies, and then by in addition, heat map I had a word there and I tripped over it, but the idea then that perhaps the most current, say, partitions that you've loaded and want to run analytics on would be in memory, and then you could roll or tier out that data as it got older into either flash or onto disk, and essentially evict partitions that were no longer being hit as heavily for, say, analytics. And so you could automate the kind of rolling partition framework for, in addition with database and memory. And so ADO policies were extended in 12.2 to database and memory. And then that opened up being able to track heat map data as well. So spent a long time on that, but that's kind of the background of all of this and where heat map kind of fits into the picture. But there are some, we'll just discuss a little bit more about heat map. So some of the details. So again, conceptually pretty simple. It's the idea of tracking access. Initially, the access we were tracking was just literally access to the object. So if you scanned it or changed it or did actually a lookup on the data from, say, an index access, we tracked that with heat map. And the idea was really a longer term access. And so I want to keep that in mind as we talk about heat map. The idea wasn't, certainly not originally, and even now isn't really on a minute by minute or a very fine-grained access. The idea was to keep more historical view of heat map data and access of objects to base either ADO policies or even usage information on that data and how it might be accessed and be changing. It's not, it's on a best effort basis. So there isn't, it's done in memory. It's possible to lose access data if it doesn't get flushed from memory, because it isn't supposed to be transactional in nature. It's just information being tracked over the aggregate and long term. And so, and that becomes important as we talk a little bit more about how this works. And that also makes the cost of turning on heat map and tracking that information very, very low cost. So we say typically less than 5%, but usually it's in the one, maybe not even 1%. It's because it's just memory. We're already tracking that in Oracle database anyways. And so it's very low cost. It's not going to cause you performance problems by enabling heat map. At least that's the idea of it. I haven't ever had anybody complain about it. It's enabled with the initialization parameter heat_map. You set it to on, by default it's off. Again, the best effort part is that we're always writing the information into memory, and then periodically we're flushing that to disk so that it can be accessed. I'll show you a couple of tricks that you can use to get that data in more real time. But again, keep in mind that it's really meant to be much more of a longer term window into the data. So it isn't meant to be up to date at the minute, every single minute. There isn't it's just too much activity, and that wasn't the kind of the picture of it, although we'll talk a little bit about that. The other big thing that we added with the in-memory part, though, is this frequency numbers, or not only do we track now the access to the data, but also the number of times the data is accessed for full scans, lookups, and segment writes. That becomes more important with database and memory, since we're more interested in a finer grained picture of the activity of the segment, as opposed to just worrying about is it being accessed? Do we over days, weeks, months, even years perhaps? Do we want to move, tier the data, or compress it? So from an advanced compression standpoint, it really is a much longer term time frame that we're interested in, whereas within memory it's a little bit shorter, and we are interested in frequency numbers, how often these things are occurring within a given time period. How was that, Greg? Is that a pretty good lead-in?
I understood it, so it sounds pretty good.
So far we're doing a bang-up job.
Yeah.
Okay, I haven't seen any questions yet, so I don't think we've lost anyone, which is good. So as far as tracking goes, and I kind of already mentioned this, but I reiterated it. The slides will be available, and of course the recording, so you can go back and look at this. But some of the details, we're only flushing the data in memory every 10 minutes or so. And so again, that goes back to this idea that it isn't supposed to be, fully transactional every single point in time. It's just at the aggregate level what's going on. It is possible, and I have some other slides as well, as it says here, actually at session exit. So if you're playing around with this and you don't see the data in heat map when you query, say, the $V views, it is in memory. And so in order to flush it to the segment level memory, there's kind of multiple levels. Again, it's really a cost perspective, keeping this as efficient as possible. Session exit, or every 10 minutes. And then there is also the ability to flush all of the data that's in various memory, whether it's at the session or segment level, to disk with a dbms ILM command I have at the bottom. So a little cheat sheet for you if you want to play around with this, and you're looking at this like we will in point in time, as opposed to that idea of maybe every 30 minutes, hour, every day, every week, whatever your time frame is. AIM also makes use of the underlying heat map information. So I have this in here from a database of memories perspective, because not only did we incorporate ADO first with advanced compression and then database of memory, but AIM, which is automatic in memory, which we added in 18C and then really enhanced it in 21C. We're heading towards that, the ability to manage the column store completely based on usage statistics. And all of that underlying information is within the heat map infrastructure. So it doesn't, you don't have to actually set heat map on for AIM like you do with ADO, but we still use that underlying information that's being gathered with AIM as well. And so we've done a couple sessions on AIM and actually ADO as well. So you can go back and take a look at some of the details, but I threw this in just kind of as just a reminder. And again, notice that the default of 31 days, and that changes in 21C to a shorter window. But again, think of it as days. We're not really interested in tracking this minute by minute, although again, with in-memory, with AIM high, AIM level high, we do get more interested in a shorter time interval. But again, I won't go into the gritty details because I really do want to focus on heat map, but we do have some previous Ask Tom sessions that we've done on AIM as well. So if you want some of those details, both the 18C flavor and the 21C flavor. So there are a bunch of views available with heat map, and I'm trying to give you some of the background of how all this is set up and works so that you can then, we can then kind of take a look at it, but hopefully you can make use of this, maybe even without necessarily using ADO or AIM, but just being able to get a good picture of where your largest activity is occurring on your different database objects or segments. So we have a DBA heat map segment that requires that heat map be enabled. Again, heat map is part of advanced compression or in memory. So either one, you can use heat map. Unfortunately, currently, it's not available unless you have at least advanced compression and or database and memory licensed. And so I'm actually kind of working on that. We'll see what happens, but it would be nice to allow heat map to be used even without either of those, even if you don't make use of ADO, but no promises. There's also another view, which we've talked about in the past, the underscore sys heat map seg histogram. Normally underscore objects and parameters are supposed to be only used with support. I've never had luck, and I've got an enhancement request in to change this, but the reason this becomes important or is useful is that it keeps the count information. And so does $V heat map segment, but $V heat map segment gets flushed. It's actually recording the information in memory. And once it gets flushed, then that count information is no longer available. And so it's a little, I apologize, it is a little convoluted, but hence the slide. But the one I use almost exclusively for what I care about, and that's heat map information with counts, is this underscore sys heat map seg histogram view. And there is also a special AIM version of that that is used when in-memory is enabled, but I won't go into the details other than just to point out that it does exist if you want to play around with this stuff. And then in addition to that, we do have some packages. DBMS heat map package, so that can be queried, so you can do a table command against it. So not only can you query the views, but you can use the DBMS heat map package to query count information and object information for usage. So there's multiple ways of doing that. If you want to do a describe on DBMS heat map, you can see the different, or look at the documentation, but you can see the different objects that are available. I mentioned the DBMS ILM and then being able to flush segments. Normally you don't have to do that, but if you want to get access to the information up front or quickly, then the normal flush process, you can use that, and I'll show you that in one of our demos. And then if you want to clear heat map data, say you experimenting, or maybe you only want a certain level of period of time, because there are, it does take up space in the sysocs table, you can actually clear heat map data if you desire. And then if you drop an object, that heat map data will also go away. So I think that covers, so we covered views, packages. We know we have to turn it on with the heat map parameter. So how might you make use of the data? And I kind of put here custom uses. I've added to my best practices, just turn on heat map, even if you're not going to use ADO, because there is worthwhile data there. And so this is a query, and I actually will put the query, I didn't, as usual, didn't get time to do it, but I'll put it out, the query, so you don't have to cut and paste it off of the slide, but I'll put it on GitHub. So usually where I'll post the slides and the scripts that I'll be using, and this is one of them, on GitHub, so you can go look at that, and that is in the resources page, the link to that, which I'll have at the end of this. So hopefully that is actually on the Ask Tom page as well. So try to make this as easy as possible to get to this if you want to play around with this stuff. So bottom line, though, is using the SIS heat map seg histogram and tracking not only the time stamp of when it was flushed and the access, but also the counts. And so in this case, you can see that, well, you ran some number of full scans. I didn't do any index accesses, so lookup scans is 0, and then I didn't write anything. But bottom line is, in an active system, these numbers, along with capturing whether the objects were read or written from or full scanned, are all available. And so this can give you an idea, running some SQL, maybe ordering by a particular date or object or just an owner, or maybe all owners, but SIS and system. You can get a feel for how active different objects are. And perhaps from a database and memory standpoint, no offense there, Gregg, you might want to say those objects you populate into the column store. And then I have another one, AIM, which is what I used in one of the AIM Ask Tom office hours sessions, where we only really care about the full table scans and how to order it for AIM. And so that's an example of using the AIM version of the histogram view to get an idea of what objects would be most beneficial for in memory. And this is kind of a shortcut versus the previous query to give you an idea of what realistically, what objects you might want to populate in the column store. So this, unlike the in-memory advisor, which can be used to gauge whether you have analytic workload, you would run right on your actual workload and say, well, gee, I've got, maybe large tab 1 in this case, it's only getting, depending on the day, maybe it's not getting access very often. Some days it gets access, some days it doesn't. So maybe that's one of those big heavy hitters of usage of in memory that I don't necessarily want to have populated. So anyways, there's information there, or you could just turn on AIM high and let it figure it out for you. So where does heat map get used? And so I think this is useful. We've mentioned ADO, so automatic data optimization, in 12.1 for the advanced compression side of the picture. And am I supposed to let you speak about some of this?
I can do this one.
Okay, I'll let you go. I've done enough talking.
Yeah, I'm tired, so I'm ready to listen, ready to speak. ADO, well, first of all, heat map, as Andy mentioned, was designed when it first came out. Advanced compression was really to track where your table partitions were in terms of their life cycle, meaning that are they still being actively modified? Are they hot? Are they starting to cool down and they're mostly used for reporting, which we sometimes call warm? Or are they really getting cold? They're mostly historic type data, archive data, things like that. So as Andy mentioned, a lot of customers will turn it on just to track where their table partitions are, just to see what's going on. Regardless of using anything else, we'll just turn on heat map and get a sense for where their table partitions are in terms of their life cycle. The other part of the IAM features that are part of advanced compression specifically is automatic data optimization, or ADO. And that's included as part of the advanced compression option license along with heat map. And ADO is designed, it's a PL SQL scripting language. It was designed to take the data that sort of heat map is tracking of when was the segment last read or queried, when was the last modified down to the individual blocks, and allow you to create policies that'll take certain actions based upon that information. And some of the actions mostly come in two categories. There's compression tiering and storage tiering. And the compression tiering allows you to change the type of compression automatically based upon your data sort of aging. So as the data starts getting colder and colder, you can create policies that look at that data using the heat map information. And for instance, we'll figure out when was the last time it was modified. And you could say things like, well, this data has not been modified in 30 days. I want you to enable advanced compression. You might have another policy that says if this data has not been modified in 90 days, I want you to change from advanced compression to hybrid calmer compression, assuming you have access to hybrid calmer compression. So you can do compression tiering, and the compression tiering is simply a way to automate or create policies that the database will go through and evaluate. And when the policy takes effect based upon the heat map information, you can take actions such as change the type of compression being used. So you can have the database automatically change or automatically turn on compression in the first place, as well as change the type of compression as the data has started to age, as it goes from being hot to warm to cold. You can turn on a different level of compression, whether it's advanced compression or one of the different flavors of hybrid calmer that sort of best meets the current usage of that data. So that data is starting to cool down. It's used for reporting purposes mostly. It's a good candidate for hybrid calmer. The query level / warehouse level, if the data is starting to get really cold, it's mostly archive data, historical data. You're keeping data around for regulatory reasons, whatever it happens to be. You might choose hybrid calmer archive level. So as that data goes through its life cycle, as it starts cooling down, you can create these policies that use a combination of the heat map information and ADO to automatically enforce certain levels of compression, and you can decide at what point you want to turn on different types of compression. And the database will turn it on for you automatically or enable the compression for you automatically. And likewise, there's also compression tiering. So if our storage tiering, should I say, sorry. Likewise, and as Andy mentioned, originally the idea was we'd have different tiers of table spaces. You might have a high performance tier and a lower cost storage tier, whatever you want to call them. If your data resides, say, in tier 1 and the tier 1 is starting to fill up, you can have policies in place that as you run out of space on a certain table space, it will look for the coldest tables there and automatically move them to another table space for you. And most of the ways originally was designed for you to have your high performance tier 1 probably and your lower cost high capacity tier 2, and it would be moving between from the high faster storage or the faster performance to the higher capacity tiering. But in reality, what a lot of times we see is that customers sort of have everything in this table space, and they know that they have really cold data in that table space as well. And when they start running out of space in that table space, that's when they want to go through and look for sort of the cold data, the tables partition, and have them move to a different table space that's sort of for colder data, which you really don't expect to use very frequently, but maybe just for reporting purposes or archive purposes and that type of thing. So automatic data optimization scripting language designed to do storage tiering, compression tiering. It's really great for that. It'll do that for you automatically. You just set the policies. It does require advanced compression from my standpoint in order to get those two capabilities. And as we get towards the presentation, I'll point you to a white paper that talks a little more about this.
Hey, Greg, we had a question. So I was going to type in the answer and I decided, wait, let's let you do this live. Nope. So the question was, at what storage level does ADO work for compression? Block, extent, partition?
ADO will work actually a little different from the way things work in the past. You can specify ADO at both the segment and the row / block level, if you will. So you can have ADO policies that will perform compression at the segment level, which is the way typically we've always done compression when you enable compression with Oracle. So if you specify the segment level, it'll rebuild the entire segment one time. So you compress your entire partition, you compress your entire table at one time. With ADO, it introduced a new ability to compress we call the row level. And so you can actually create an ADO policy that instead of compressing at the segment level, will compress at the row level. And what we mean by that is it looks at each individual block when it does its compression. If each row in that block meets the policy condition you set, let's say it's not been modified in a week or whatever it happens to be, it will then compress that block. And it'll keep looking for other blocks that also meet that condition. And so the next time it runs, the next day during the maintenance window, it'll go look for more blocks that meet that condition. So instead of compressing the entire segment at one time, it'll actually compress individual blocks when all the rows on that block meet the policy condition you set. So it could take more time to compress everything because you're waiting for each individual block to meet the criteria. But the interesting thing about that is it does not require a rebuild. So unlike segment level, which requires you to rebuild the partition or the table, when you specify ADO at the row level, it actually compresses individual blocks. It does not require you have additional space to rebuild the entire segment. So you can actually rebuild at the block level as each block meets the criteria you set.
Great, thank you. So
Yep.
we have another question. Is there any difference on how in-memory works on a regular infrastructure and an Exadata infrastructure, I assume? And yes, so the difference, and I assume this is more generic, and so you can correct me if I'm wrong, but in general, the big differences between database and memory on regular or commodity hardware versus Exadata are the ability to use the Exadata Smart Flash Cache as a second tier, if you will, for columnar storage. So you have the in-memory column store in the SGA, that's the in-memory underscore size parameter being set, or on Exadata, you can also make use of columnar formatted database and memory columnar formatted data in the flash cache. And then support for active data guard, full support for active data guard on Exadata. And what's the third one? I'm blanking. Oh no, the duplicate feature. Sorry, yeah, not the rack per se, but the duplicate feature. Thanks, Marcus. That keyed it in. And actually, we did an Ask Tom session not very long ago on duplicate and how that works. So we can duplicate IMCUs. Gosh, that's terrible. But well, you get so wrapped up in thinking about heat map and ADO or the topic at hand. Sometimes that stuff blanks. But anyway, so the three big differences. Other than that, in-memory works exactly the same. It's the idea of columnar formatted data and fast access, but the features that are also available in Exadata, other than all of the other great improvements that Exadata offers within Oracle database, are the use of Flash, the duplicate feature, being able to mirror IMCUs, or even duplicate them across all of the nodes of the rack cluster, and then the ability to use active data guard and populate columnar formatted data in the standby database, whereas on commodity hardware, the standby database can have the column store activated but won't populate it until failover. So hopefully that answers that question. Wow. All right, so looks like that's all the questions. Maybe there's some other question. Sean was also chiming in. So partial coverage, yes. I think that's what you meant by Sean, or the distribution of data. That's rack, and then the ability to mirror it. So thank you guys for helping me at my memory loss right there. And then automatic data optimization will continue on with is also in memory. And this one's actually automated. I didn't realize that I'd used this a while back, and so there you go. Look at that. Ooh. So the idea, again, same thing that Gregg was saying, is that in the column store, as another tier of storage, you can automatically create policies to evict older data as newer data comes in, and based on the policies and usage and heat map. So with that, I'll continue on, since we don't want to belabor the point too much. And then what you want to talk about, automatic index optimization. Correct.
So this is kind of interesting. This is actually kind of cool. In 21C, we introduced the ability, which if you want to think about it, is sort of ADO for indexes. And this allows you, it uses the same type of framework, it uses the same type of policy conditions that you can set with the ADO all along. You can say you set a policy, and the policy takes effect based on the information it tracks through heat map, and you might say this policy goes into effect if there's been 3 days no modification. In this case, you can actually specify an index. And the interesting thing about this is that instead of having to tell it, as we did with sort of the data side, if you will, what type of compression to use, if you want to use hypercolumnar or whatever you want to use. This one, you just say optimize. So you set a policy condition, and you can see down the left-hand corner there at the bottom, and you say optimize and the policy condition. So optimize after, let's say, 3 days no modification. So in this case, for the index there, if there's been no modification for 3 days, And then what the database will do when it has this optimized ADO is it'll go actually look at the index and it'll figure out the best way to sort of save space, or I guess the probably easiest way to say, or sort of optimize that index to not only save space but make it a little more efficient, if you will. And there's three ways it can do it. It can compress the index, it can coalesce the index, or it can rebuild the index. And this isn't something you have to figure out. The database will actually figure this out on its own. So when the policy conditions met, it goes out there, it looks at the index, it thinks about, what's the best thing I could do with this thing? Should I compress it, coalesce it, rebuild it? It'll figure out on its own, and it'll actually implement whatever one it figures is the best way to achieve it, the goal of either saving the space and making it more efficient, etc. So it's a little more streamlined, if you will, I guess, is that it doesn't require you to sort of make a choice what to do, whether to which type of compression or anything of that sort. The database will figure out for you. All you do is set the ADO policy, set the conditions, and it'll figure out sort of what to do with that index when that policy condition is met. And so that is something new in 21C.
Cool. And then AIM, which we kind of mentioned, so I'm not going to really dive into AIM at all. We do have a couple of sessions that we've done in the past if you're interested in learning more about how automatic in-memory works. But bottom line is, even though it doesn't use heat map directly, you don't have to like enable heat map. But AIM uses under the covers the same basic data being captured that heat map captures for ADO use. And then in 18C, and then I kind of mentioned in 19C, there's this version, the ability to have a high. So we added another feature at in-memory automatic level. And then we really do fully automated. It basically enables all objects to be populated in the column store. And then the activity, heat map activity, if you will, drives the population of the column store and the contents. And so that's actually really cool. I'd highly recommend, if you're interested in that, taking a look at our previous Ask Tom session. I do a demo of it. It's actually quite interesting, and really where we're headed on the in-memory side with tracking object access. And where can you get more information? So I'm going to stop here. We have a little bit of time, and so I'm going to bring up, hopefully, just a real short demo of how this works in practice. Because even though you might use it for ADO, you might also decide that you just would like to use, can you see it, Greg? Is that there?
I can see it.
Okay. You might just want to use it just to track stuff. So even though you might not have the need, or maybe you do have the need for ADO policies, but in addition to that, you'd like to mine some of that data to know, could I compress this data more? Could I put this data and lock it into the column store? Whatever. So what I have here is our SSB schema, the line order table. This is actually, you might notice at the top says Live Labs. And so this is actually the new version of Live Labs that I've been working on. And so what I've done is part of that, and actually to support ADO and AIM, is I've partitioned the line order table. So in the new Live Labs version, which should be out fairly soon, the line order table is partitioned by year. And so I have 5 partitions. And so that's all that important, other than just understanding that makes it easier to demo, for instance, evicting objects, because rather than evicting, I'm looking for my notes here on what I was going to run. Rather than evicting the whole line order table, you really might evict the 94 or 95, because those are older data, and then 96, 7, 8 partitions, which might be the newest data. Yeah, forget about the year, but that's just the way it got generated. I might only have a subset of the total table populated. And so one of the labs is an ADO lab to actually simulate that. And so for our purposes, whoops, please don't tell me you locked it. I have that data populated. I have this just to show that I've set heat map on. So that's the parameter in the initialization parameter or file, the init.aura, that you would set to, or alter session or alter system, I guess, if you wanted to set heat map on. So I've set heat map on. I've populated it in the column store. This works just the same. It's funny because I didn't say this, but I should have. Heat map is really tracking access to the object, whether it's in memory or not, whether it's on disk. Because remember, if you have an object in the column store, it always exists in the row store. So it's really just tracking access to the object. The part of in memory is just because I do in memory, so I always use that as my example. But realistically, I didn't have to populate this in the column store to get this information. It just makes accessing it a whole lot faster. So so that we got that, we showed that. So I'm going to show you. So currently, there might be some heat map data, but I don't really have anything from today. It looks like a little bit from today is the 22nd. So it looks like, oh, it looks like it did show up. So it says the tracking time is here. Notice that we have our counts. And what I did is I kind of wanted to show this in action. So I wrote a PL/SQL procedure. And again, this is kind of to generate information that just basically is going to go access those objects. And all it is a full scan, basically, selecting the total order price, summing it from line order based on dates. And so the idea was this is going to go looping through and access each of the partitions based on date. And then notice at the end here, I just ran a flush all segments so we could see it then, flush it out of memory. And then if I rerun our heat map query, we can see that those numbers, so we're 1041, whoops, and 1143. So we get multiple timestamps. Now notice one of the reasons for that is that because I accessed the data, I did a full scan against it. And so this is where you have to kind of take a look at how the data was accessed. And then over the period of time, this gets aggregated such that you can see the totals rather than having it broken out. Some of this is available in Enterprise Manager, but it's at the daily level. So in Memory Central or in Enterprise Manager, it also mines this data. Notice, should be remiss if I didn't point out that what I'm doing is I'm accessing, again, the heat map seg histogram, and then combining that with objects so we can get the object name out of all of this. And the other thing I was going to point out, I had one more query, and it's really just a simple query just to show the fact that you can then get usage statistics fairly recent by flushing the data out of memory. Is this one, and this query uses, I'll go back in a second. Whoops, I didn't echo it. Sorry about that. So I mentioned there were multiple views available. And so this uses DBA heat map segment. The only disadvantage to using DBA heat map segment is you don't get the counts. So this is going to be on essentially like a daily basis. And here we get the last time the segment was written to, read from, full scan, look up, and if I haven't done that, and I segregated this to, actually maybe this one I just did everything. The other one I did it based on day. Yeah, this is just what I have in the system. And so it was already loaded. That data was already loaded, so it doesn't show like writes for certain things. So those will be blank. But since it's in the database, you can write SQL to create your own custom mining of all of this data. And so I will put these queries, not that you can't cut and paste them off the slide, but I'll put these queries in GitHub. So if you want to maybe play around with this, maybe you haven't really looked at heat map. Again, very simplistic. I'll actually make the generating stats if you want to do that. It's just no biggie. It's just PL/SQL. But the idea that you can actually glean information about how the data was accessed and the number of times, I think is kind of interesting. So that was the whole point of doing this and making this information available, because we haven't, I don't know, Greg, maybe you've done some previous information on it, but I've never really talked in detail about heat map itself. And so I thought it would be kind of fun to explore this a bit.
Yep.
And with that, let's see if there's any other questions. Again, pretty simple demo. We'll make the slides available. If you want to experiment with this, for this, you can, our Live Labs environment, you could go try it out. You could try it out in a VirtualBox if you wanted to download like developer days. All of this has been part of the database since 12.102 and then 12.2. It does, remember, require a license, so be careful about turning it on in your production environment unless you're licensed for ADO or ACO, advanced compression option, or database in memory. But you can experiment with this and maybe it makes sense. I don't think you're going to buy or license either the options based on heat map alone, but I think if you do have those licenses, heat map makes sense to just turn it on and capture that information. So with that, anything you want to add, Greg?
Nope. Can we go back to slides? I think we had some more information
right.
stuff there.
Thank you. You're right. We do. So let me flip back here. And more information. So I tried to include all of the places where the various pieces that we've talked about are documented. The big one is the VLDB and partitioning guide. That's got all of the ADO, all of the heat map, everything part of the segment information. The reference, which documents the different views and PL SQL packages. Actually, the views, the $B views and the DBA views, so the static and initialization. Then the PL SQL packages and types reference, which has got those packages documented. And then AIM is available in the memory guide, 18C, 19C, 21C. I should probably add that. Anything else? Do you have? I have some blog posts that cover some of these and the Ask Tom sessions. Do you also have blog posts where you've talked about any of this?
Yeah, so I put a slide in here at the end.
Yeah, we did. So our Ask Tom office hours sessions, and that's our blog, the in-memory blog, and then the resources page where you can go, for instance, Live Labs link, the GitHub link, or if you want to go download, I'll put the slides that we talked about today, along with a couple of scripts there. You can get to it. And then Gregg also has a blog available. You have at the very bottom there, right?
The very bottom one, or
no, it's the second one.
It's the second one down is a blog for database storage, mostly about compression. If you go to the last one there, which is the ACO, the advanced compression page on o.com, oracle.com, if you go about halfway down the page, there's a bunch of white papers. One of them is on implementing IOM with Oracle database, and it talks about heat map and ADO and all that kind of fun stuff. So it's a good way to kind of review, not so much the IAM stuff, database memory stuff, because it doesn't really cover that, but it covers the earlier releases and the on-disk ADO and heat map for that's included as part of advanced compression option. So
great. So I hopefully this was a good primer to kind of let you guys know about what heat map does, what it's capable of, whether it makes sense for you. You try it out and see. Hopefully, if you have the licensing, you can make use of those in your environments. Maybe play around with that a little bit and see what works. And that's all I have. I don't see any other questions. Anything else you want to mention, Greg?
No, that's all I have. Thank everybody for attending, but yeah, I don't see any other questions, so I have nothing else to add.
Okay. Yes, thank you everybody for attending. Look for the next version of Ask Tom office hours. My plan is to talk about JSON and JSON with database and memory in the Oracle database. We'll see if that pans out. I have a special guest I'm hoping to get willing to come share his knowledge of JSON. And then we'll talk about how that works in database and memory. Hopefully heat map is something that was of interest. And again, if you have questions later on, feel free to email either one of us. And thank you very much for attending.
Thank you, everybody.